In the last video, I introduced the logarithm function, which we use to calculate what power we must raise one number to, which we call the base, in order to equal another number, the argument. From the laws of indices, I derived the corresponding laws of logarithms, which apply when we combine logarithms with the same base in an equation. I also introduced the special number e and the exponential function e to the power of x, alongside the corresponding inverse function, which is a logarithm with base e of x, which we define as ln x. In this video, I will do some exam questions on solving equations using logarithms. The first two I will do will be using the laws of logarithms to solve equations, and the second two I complete will include the harder task of linearizing equations using logarithms, to then subsequently solve them. For this first question, we are given a logarithmic equation which includes the variable x, and our job is to solve it for x. We notice straight away that the base on each of the logarithms is the same, and so we automatically have a feeling that we will be using the laws of logarithms. Our aim is to get an equation which has a logarithm base a of something on either side of the equal sign. This is because if the log base a of one expression is the same as the log base a of another expression, then those two expressions must themselves be the same. First, we use rule 3 to rewrite the second term in the equation. Next, we use rule 2 to combine the two terms on the right-hand side into one term. Now we can simply equate the two arguments, and we have shown that x is equal to 12. In a very similar fashion for part B, our first instinct is to use rule 1 to combine the two terms on the left-hand side of the equation. This function on the left asks what power must I raise a to get 5y, and the answer is 7. Therefore we write that a to the power of 7 is equal to 5y. This gives us the result that y is equal to a to the power of 7 over 5. In the second exam question, we again notice the matching bases and so aim to manipulate the equation using the laws of logarithms. The first term can be expressed as this using rule 3, and when combined with the second term using rule 2, we get this. Equating the arguments, we obtain this equation here, which after rearranging can be expressed in the required form. To solve the equation, we must simply factorize. These two exam questions are much harder and demonstrate a technique we use logarithms for, which is linearizing equations. This is when we have a difficult equation involving indices, and we want to turn it into a simpler equation involving logarithms. Now we use the logic of equating the arguments of logarithms with the same base in reverse, and say that if we have two expressions that are equal, taking the logarithms of both expressions with respect to the same base, which will result in two new expressions that are also equal. It doesn't matter what base we choose to use. It is common to use a log base 10 or a ln, which is just log base e. We will then use the rules of logarithms to manipulate and solve the new equation. For the first question, I'm going to choose to apply a log base e, a ln, to both sides of the equation. We then use rule 3 to rewrite both of the terms. After we rearrange a bit, we obtain this equation. Notice that the terms ln 3 or ln 5 are no problem to us, since we can just type them into a calculator and it will work out their value for us. When we type this expression into a calculator, we obtain that x is 146 to 3 significant figures. For this second question, we see that the form we eventually want to express x in involves log base 10s, and so when we apply the logarithm to both sides of this equation, we will apply a log base 10. Using rule 3, we again rewrite the equation in a new form. We then expand out the brackets and move around some terms before refactorizing out the x on the left-hand side of the equation. We then tick through each logarithm term in our equation and apply rule 3, so there are no coefficients in front of the log base 10s. This allows us to combine the pairs of terms on both sides using rule 1. When we then divide on both sides, we are left with the final answer that x is equal to log base 10 of 486 over log base 10 of 144.